Hi there, and welcome to episode 7 of Startup Disc's Full Tech Chat. My name is Bruce, and I'm joined by Jay and Dana. And today we're talking about 3D printing. And to help us on this journey, we have two very special guests, Eric and Kate, who are both avid 3D printers. Welcome to the show, Eric and Kate.
Hello.
Welcome.
So I'm going to just kick this off with a bit of a question. This is for all the newbies out there. I'm going to say, Eric, why own a 3D printer?
3D printing is the ability to make what you do not have. You can design, you can find, you can take the thoughts, the ideas, you can take data from your computer and you can turn it into something physical. The same advent of the traditional printer and the two-dimensional paper that we saw take the entire world by storm. Whole industries, entire industries, whole different major Fortune 500 companies were born of printing as a concept, because when you have the ability to transpose a thing onto a new medium, the human brain just kind of flips into a new dimension of concept. So when you think of the ability to have something as simple as a picture of a car on the internet that you can then hold in your hand the next day because you wanted to, you start thinking, well, how do I take that and do something else with it? How do I apply that to more? And when you think about the idea of not having to purchase every single good that you own or every single good that you would like to use, the reason of why to own a 3D printer isn't really a question anymore. It's more of why would you consume protein? Why would you walk? These are functions of different goals that we didn't know were achievable.
Well, I mean, you made a very good point there where you're talking about printers. And let's face it, I think you would find in most households that have a computer, they're probably likely to have a printer. A 2D printer is in something that prints onto paper or some other form of substrate. So we see these in as I say, most homes with a computer are going to have a printer, but 3D printers are still probably a little bit more boutique, I suppose, not as many people. Do you foresee this as being something where in the future, like every home could potentially have a 3D printer?
So I'm glad you asked this way. Being in systems engineering and IT as a profession for the last 14 years of my life, have, as one would assume, grown to hate traditional paper printers as part of my job, because for many reasons. So I made a very strong and cognizant effort to never own my own paper printer. And I succeeded at that, actually, since I left my parents' house at the age of 19, 20. So for me to be as gung-ho, I'm constantly thinking about this. For me to be as gung-ho about 3D printers as I am, I constantly worry that I'm becoming my grandfather, who took his home technology hobbies, which his was audiovisual, way past what the normal home hobbyist would. I worry that I'm doing the same thing, but then I start seeing all of these genuine novel applications in every aspect of every society that 3D printing is fulfilling, from automotive to biomed to a traditional engineering office, architectural firms. People are using it for fun, for home, for kids, for toys, for models, for Dungeons and Dragons. Oh my gosh. The why is always answered by the self in every type of deposition, and that is what it comes from, FDM. It's fused deposition modeling. So as you depose, you are deposing concept to medium, and as long as there is a human need to create, 3D printing will achieve commonality. And so long as you have electricity and the internet, you have the resources necessary to create at home now.
No, yeah, it's fantastic. And look, we'll probably get onto some of those, different, uses a little bit further on. But I'm going to sort of, bring it back into the, sort of the basic stuff. And Kate, this question is directed at you. How does a 3D printer work? For the layman's out there,
Right.
How does it actually work?
So for your typical 3D printer, they're usually called FDM printers. So you're laying out layers of filament or layers of material over and over. And A typical filament comes in rolls like this that weigh about 1 kilogram. And what the 3D printer does, at least an FDM printer, is it pushes out this filament, kind of like a tube of toothpaste pushes out the goo, and it's heated up at the tip so that it lays down the filament in the right shape that the computer tells it to move in, right? So you're laying down the plastic layer by layer, heating up the filament as you go. And while I know we're not going to get into the resin printers. There are other types of 3D printers, like things that can print with metal, things that deposit different types of material in sand and then dissolve that material to leave like a casting. So there's different types of 3D printers, but your typical at-home 3D printer that we're talking about, the sub-$1,000 3D printers, what you call a FDM 3D printer that deposits layer by layer of plastic.
So we're sort of, so we're taking, we're taking a solid plastic, heating it up till it melts, squeezing it out to then, sort of create layers, and then just one layer upon the next layer upon the next layer. So sort of like the same way that you would, say, build a brick wall by laying down the courses of the bricks to then sort of build up a house from the bottom up, that sort of thing.
Exactly. Right.
Yeah, excellent. And
I know we're not going into that, but have you ever seen those construction size printers that just print a damn house on the
Concrete.
spot?
Yeah.
That's a good example
Squeeze
of
that concrete.
I was just
an FDM type printer where you can actually, the layers are like that big around, so you can see the layers going down. Printers now are
really
getting
cool.
so high resolution that the layers are getting.
What do you think that nozzle's made out of? It can't be brass. What do you think they made out of?
Well, it's not heated, so it can be. I don't know.
Do you think the nozzle has to move actually? That because it's concrete and it constantly has to be moving to avoid any dry spots? I bet it has to.
Maybe some kind of thick rubber or something.
Yeah, I mean, I guess they have to, once they start, they have to keep going, don't they? I mean, and of course, I mean, I've seen like a great big 3D printed boat. And of course, I've also heard talk, again, this is conceptual stuff, but I've also heard talk about the idea of, if with, potential space travel in the future or landing on another planet or, going to Mars or whatever, that they would then be looking at using some of the raw material to 3D print enclosures and stuff when they get there, which is interesting. And again, that's all just conceptual stuff, but this is some of the stuff that they've been talking about when they go and do something like that. So, okay, so we've got the 3D printer. I can actually see one in the background there that you got there, Eric. We've got this, this 3D printer. We need some filament. We obviously needing to heat this filament up in order to get it hot and everything. Are these expensive machines to run? So, I mean, are we talking about something that's, going to dim the lights when it starts rolling? Is that something you can answer for us, Eric?
There's so many aspects to that question, and I'll try my best. And I like the way that you phrase the question. Is it expensive to run? Because most people end a lot of their questions on, is it expensive? And is it expensive to run, I think, is the most appropriate question. So thank you for phrasing it that way. Is it expensive to run asks three different questions. One, is it expensive to obtain? Two, is it expensive to run, as in load it with filament, draw electricity? Or, God forbid, you paid for a model. Number three would be a bit more subjective to the user. And that's where I think things get the most interesting. So let's start with the easy one. Is it expensive? 3D printers right now, the most commonly used printer, and I think we'll all agree in the world, is the Ender 3 from Creality. It's everywhere. Refurbished from ComGrow right now. You can get them for $70. $70 you can get a refurbished Ender 3. $109 you can get an Ender 3 V2, which is the one that has the most quiet stepper drivers inside of it. It's got all of the modern fixes to the cooling solutions. It's got the quietest running, and it has upgraded speed. So I mean, it's delightful. So no, it's not expensive. But if we take a look at Kate's screen, she is sitting in front of a $1,500 printer that does the exact same thing conceptually. That is the Bamboo Labs X1 Carbon with the AMS.
Right.
That is first of all, Kate, I can't wait to hear you talk about it. By the way, I saw you had a video about it. I know that. Please plug that because I would like to revisit that later, and I'd like the users to go back to
Yeah,
that video.
definitely.
It's wonderful. There's so much to talk about there, but it's not necessary for every job. Filament can range very much. So if we're going to talk about PLA a lot today, and PLA I think is like probably like 70% margin of the most filament used of all the different filaments. Plastic, polymer. They're as she said, it's 1 kilogram spools. They range from anywhere between like $12 a kilogram up to like $60 a kilogram just for normal PLA. And that's before you start talking about what we call abrasives or additive materials. We call those abrasives because they fill them with carbon fiber. We have different types of glass-filled polymers. We have nylon. So when we talk about these abrasives, we talk about heat demands, we talk about nozzle materials, we talk about enclosures and poisonous gases. We talk about a lot of different things. And that's when you start to incur substantial costs. So let's talk about nylon just real fast. You're talking about a $40 tent. You're talking about a $50, and this is my Ender 3 still, my $70 Ender 3, not mine, but theoretically. You're talking about a $50 hot end upgrade. You're talking about either changing the firmware, which is very dangerous to do with typical Marlin firmware, or buying a Raspberry Pi, running Clipper, and overriding everything to run at 300, 400, 500 degrees Celsius. You're talking about keeping the enclosure ventilated to make sure that the noxious fumes don't enter into your room. And you're talking about double to triple the cost per spool of material, as well as talking about what we call dryer boxes, which is how you have a desiccant that removes all humidification from a roll and keeps it preheated to a specific temperature. So that's another $60, $70, up to $120, $130 for home usage. So yeah, it can be expensive, but it doesn't have to be. You can buy an Ender 3 for $70, buy a $20 spool of filament, and use the computer you have at home, and you can start printing. Absolutely. But you might not find that it solves every need that you have. The real hidden cost that I wanted to touch on, though, was the expense that goes into the finished product. I've noticed with the communities that I'm a member of, the concept of materials that can't be printed often eludes those who think, I have a 3D printer, I can have what I want. When you think about things like fasteners, when you think about things like nuts, bolts, paint, glue, anything you're going to use to mount something with, all these are hidden costs. So you can design things for free. You can print things for cheap. You have to ask yourself, at the very beginning, is polymer strong enough? And if so, how much more polymer do I need than a typical metal thing? If I have a small little metal bolt that's holding two blocks together, that metal bolt's probably fine. But if you print that in plastic, you're going to have to double or triple size that to get close to what we call a shear strength. So you're going to need to compensate for that, which is where we start talking about designing things that are right-sized and toleranced correctly for their application, unless you're willing to come out of pocket and spend for the metal.
It's very interesting. I mean, you have brought up a whole bunch of things there that I would not have even thought about. So, Kate, you wanted to say,
yes,
follow something up? Yeah.
Regarding expense to run, I think one thing that I think Eric was about to get into was time. Time is something that is also an expense. And that's having had a Creality printer in the past, which I had the original CR10 that came out in 2016. That was my printer. That was my only printer. And having done multiple hot end swaps, changing the heat bed, using different nozzles, different Bowden extruder types, I spent a lot of time upgrading a cheap machine. So when you talk about, is it expensive to run? You can get into, printing out little doodads and cats and making earrings and printing out little cute things for your house relatively cheaply. But there is that you're going in for a cheap printer. It may not last as long. It may need more tweaks. You may need to spend more time learning how to tinker with it and calibrate it, get that bed level just correct. If you spend a little more and get a printer that has some of that automatic bed leveling built in, it has, a hardened nozzle built in, it has a webcam built in, it has built-in Wi-Fi, then you can skip a lot of that tinkering steps. And that's that's why I ended up getting this Bamboo Lab X1 Carbon, because I was realizing I spent a lot of time, and my time was more valuable to me than building up in my CR10 that I've had for 5 years.
I have a question for you, Kate.
Yes.
What was your first chosen printer upgrade where you didn't have a break, but you chose to spend money on an upgrade? And then conversely, what was the first thing that you actually wore to the point of breaking on that first printer to replace? Because this is always fascinating to me.
Right. The first upgrade I did was the auto bed leveling. So the BL Touch is what they call it. And essentially what that does, bed leveling is a tough nut to crack with your cheaper 3D printers, because you have to make sure that the bed is as level and as flat as possible. Or you can have software that compensates for the minute curvature of the bed. So that little sensor, essentially, it senses how high different parts of the bed are. That was my first upgrade that I did. And that definitely helped. It made my life a lot easier for a bit of time. And then what went to failure was there's a little gear, the extruder gear, and they're made out of brass. They're really soft. And I'm sure I see Eric, you're nodding. So any person that 3D prints a lot, that brass gear is pushing the filament into the extruder. So over time, the filament is, even though it's plastic, is going to wear down the brass, because brass is relatively soft metal, and that's a replaceable part.
For me, it was the belts. I kept snapping belts like crazy because I was over tightening way too far.
I should actually I'll just give a little bit of an intro to this, and then I'll hand it over to you, Jay, to talk about this, because this is actually, I find this a very interesting part of this journey. Both Eric, you mentioned the Ender 3 V2. Both Jay and I bought one of those. Jay bought it first. And I had a plan to buy a 3D printer, and I was going to get a Snapmaker, and I was just saving up the money for it. And then Jay got the Ender 3 V2, and he had done quite a bit of research on it. And the price point for it meant that I didn't need to save up for it. It meant, you know what, I can do this as a spontaneous purchase. And when I started looking into this, that was why I then sort of went with the option to go with the Ender 3 V2. And for me, the journey has been fairly good. I did what Jay had done a lot of research already. He sent me a whole stack of videos, and I watched a video on assembling the Ender 3 V2, some tips and tricks for assembling it well. It gave me a whole bunch of videos on getting started with 3D printing, the things you need to calibrate, what you need to do, all of these different things that help you along the way. And I watched all of those before the printer had even arrived. And I even I had a lot of people say one of the problems with this printer is a couple of these things aren't the best quality. Buy better ones. So when I got my printer, I literally put together a printer with different bed springs on it and a different Bowden tube, because these are things that people said, upgrade these things from day dot. So I built my Ender 3 V2 printer using slightly upgraded parts than the ones that come with it. And I had no trouble with it at all. I was printing things that were looking really good. Okay, yes, a little bit of finessing here and there, but ultimately it came out of the gates working really well. Jay, not so lucky. Exactly the same printer, but Jay, just quickly tell us a little bit about your 3D printing experience.
Yeah, I had done my homework. I had watched the videos. Same thing, learning about common failure points. What to expect before you get it, and I did everything right. But whatever I printed just didn't work. I don't even remember most of it because I tried to kind of forget about it. But prints didn't work. The bed wouldn't stay level. Even with the BL Touch, it wouldn't work. Whatever could go wrong did go wrong. And I spent a month, day and night, sitting here. I mean, COVID, didn't have anything better to do but work from home and sit here and 3D print. I spent days, weeks, up to a month trying to get it to work. when I finally decided this is a lemon, I'm sending it back, and I got another one. And the second one worked. But by that time, I hated 3D printing so much that I just kind of never did anything with it ever again. So, yeah, I really missed out. I could have been printing now for a year. Or did you say 2 years?
2 years. 2 years. Yeah.
And I had plans, man. And we'll talk about this later. You got this website, Thingiverse. They had this really badass T-Rex skull. And I wanted to print that for my kid. Never happened. You know, my wife picked out jewelry and I had a list of stuff to print miles long. None of it ever got printed. And it's a shame because now when I think about it, like, okay, I got it set up in the basement. It's in an enclosure. It's ready to go. I have to relearn everything because this whole industry or hobby or whatever you want to call it develops so fast that everything I knew is irrelevant. I have to start over. So now I'm like, maybe next week, maybe the week after that, maybe next year. So.
Well, hopefully we can reinvigorate your.
Yeah, I've been trying. I've definitely been trying. I've been giving him a nudge every now and again. You know, got to get that thing out of the basement and start up again. So I'm sure we'll get him eventually. So. Now, okay, so we've talked about this, you know, this Creality Ender 3 V2 that is a very popular printer because of its price point. And ultimately, yes, because of, I mean, I've heard a lot of people that have had problems with build quality on these things. For example, one of the issues I had with mine is the bed is not completely flat. It bows in the middle. So when you're trying to level the bed, you're ultimately wanting it so that wherever the head of the printer is, it's the same distance away from it. And you've basically got 4 little screws at each corner that you twiddle around with until you get that level right across the whole thing. Now, if you end up getting the level right at each corner, but the distance is too far in the middle, it's because the bed is bowed. The glass is not completely flat. And this is an issue that I had with my printer. And of course, this is something that a lot of people can get caught out with. And this is not a problem you're going to have with a more expensive printer. Now, I was able to get around this issue by using a few pieces of, I'm going to say, aluminium foil. In the middle of the bed, and it worked a treat. I mean, I appreciate that it's not going to give me micron accuracy, but for what I print, it's been great. And as far as I've never had any real bed leveling issues since, you know, fixing that up. I did have an issue with the switch on the printer, which was the switch that detects when it's hit the home position for the Z-axis, and the switch that came with it was rubbish, and I threw it away and replaced it with a better quality one, and ever since then it's been perfect. So I've had no issues with it at all. But this leads me on to this next question, which I'm going to throw at you, Eric. What do we consider must-haves? If you're out to go buy a 3D printer, what do you consider is you really should be looking out for?
Oh my gosh, it's such a great question. There's so many things to consider. The number one thing to consider is, why are you doing it? If you have any answers, large, small, potential, for sure. And if you can answer any of these aspects of what you'd like to use it for, the number one thing I tell people is to oversize your print bed volume. You will see imperfections in build plate glass. You will see some warp. It does happen. But if you have a larger build volume, and Kate again will be. I'm going to tap her shoulder and ask her to speak up later when we get to the X1 and all of its fun nuances. Right. When you talk about the different types of kinematics that go into leveling and understanding the different ways of orchestrating a head to a bed, there's different ways to compensate for those imperfections. So to rewind for a minute, when you say that you have an Ender 3 V2 just sitting right behind me over there up against the wall, it has the exact same thing. I have the inability for my bed leveler, which I have a BL Touch running Raspberry Pi, running Mainsail, running Clipper. I run a 15 point by 15 point per print mesh that automatically senses all the glass. That doesn't help. I still have an imperfect bed, and using that logic, I don't have the ability to compensate for every single aspect of it with that glass. So what you would do is, if you don't want to buy a Raspberry Pi, you don't want to buy a BL Touch, you want to buy a cheap printer and you want to succeed, we do what's called rafting. Rafting is the ability to lay down diagonal layers that oppose one another for anywhere between, like, I don't know, 2 layers up to like 3 or 4 millimeters to accommodate for those imperfections, to create a level platform, because you know that your motors are true. You know that your gantry is true. So if you can get yourself an imperfect playing field that acts as technically it's a fluid-based medium to then start printing on top of, that you can get past all those imperfections. So when you ask me what to look for when you're looking for a printer, get the volume right first, and then learn how to use it. If you have the money to afford something with every bell and whistle, every perfect build plate adhesion module, every perfect webcam tracker for different layers, if you have the ability to connect to it over the network, that's all nice. You can still succeed with the low end printers, but as Kate said, you can you can pay your way to not have to tinker, or you can get a $70 printer and you can print $1,000, $2,000, $3,000 printer quality prints on it. It's going to take you a lot of time and energy, trial and error, and the most absurd degree of calibrations. And I'd love to talk about those at some point in time during this show. But you can get there. So when you're looking to buy, ask yourself, what all are you willing to do? Because you can spend the $70, you can try, and then you can get frustrated and throw it down into the basement, like a couple people who may or may not have done that here. Or, and I'm not saying that everybody should do this, if you want to spend Bamboo X1 carbon money, theoretically, you should be able to unbox that thing, and in 30 minutes, you should be able to print nearly perfect prints in almost every material, in any build volume, any quantity, any size, in multiple colors the first time, successfully.
So volume is a really important point that you just mentioned there. So essentially what we're saying here is make sure that the printer is big enough to accommodate what it is you want to print. I mean, every printer has a certain distance, the distance the head can travel in a x-axis and a y-axis, or the bed moving and the z-axis traveling upwards. And so, for instance, on my printer, it's around about 20 centimeters, 20 centimeters width and depth, and then I think I've got about 25 or 30 centimeters upwards, something along those lines. Yeah. Now, obviously, if you're someone who is looking to go in and print nothing but, little miniatures, little models or something like that, you may not necessarily need a bed that big. So obviously, when we're talking about volume, is making sure that that printer is big enough to print the sorts of things you want to print. I know someone who's using 3D printing to create car dashboards. Now, obviously, things like this little printer is not going to be good for that. So,
but it's not just about volume, too. It is also about orientation. When Kate said it's doing one layer, then going up, and then doing the next layer, that's really important. Because let's say you wanted to print, if you've ever gone to the hardware store and seen the sheets of plastic or Lexan they sell for whatever needs you have. If you wanted to print that on your Ender 3v2, the cleanest and easiest way would be to print it flat, and then you'd be limited by your 235 millimeter squared, flat orientation. You could print it much larger vertically, and you could print 20 of them in a row. But you have then what are called layer lines, and you have the potential for what is called layer shift. So if what it is that you want to print must retain its structural integrity, thinking about where layers occur compared to what could theoretically retain stress with whatever the end purpose is of your print. I like to think about that sheet of Lexan often, because if I say you buy a sheet of plastic at the hardware store and you set it on top of 2 different bricks, you'd be comfortable putting your beverage down on top of it. Be no issue with that. But if you were to 3D print something the exact same thinness, and let's say it's a 1 square foot or something similar, 1 square meter, which is even larger, where you have even more stress points. You want to get down there and you want to look at it and see, wait, am I gonna fracture this? Did I have any layer skips? Because if it's printed vertically, you're gonna want to be concerned about whether or not you have the slightest imperfection, because you can just crack it right in half. So think about volume, as well as orientation. Because if you don't care about the strength, that volume is whole. If you care about the strength, that volume is linear.
Yeah, sure. Yeah. No, it's a very good point, Ken. It's more stuff that I hadn't really thought about. So I'm glad you're here.
I would like to add something from my perspective when it comes to must-haves. For me, the reason I went with the Ender 3, which one do I have? The Ender 3.
V2.
Yeah.
V2.
Okay, that one.
Basement edition.
Is I wanted it to be affordable, but reliable. And the Ender 3 came miles ahead of anything else at its price point. And the community was huge. Like all the upgrades, or most of the upgrades that you find on the Ender 3 V2 were thought of by the community that printed all that stuff and did it all to the original Ender 3s, from what I understand. And they, you can upgrade your own printer just by printing really cool stuff. And I wanted to tinker. Tinkering was super important for me. I wanted to print stuff, but before the printer was even delivered, I had already ordered my upgrades. I had the touchscreen, I had that big 3 something board, I had the BL Touch, I had
SKR.
everything. I had the dual axis. I had it all ready to go because I wanted to really tinker and push that thing to its maximum. It ended up pushing me to my maximum. Different story. So that was upgradability and not being, because the printer behind Kate, it looks fantastic, and I'm sure it'll outperform my printer any day of the week. But it's kind of like with modern computers. I prefer a slightly older computer that I can tinker with and upgrade than a new one that's an all-in-one and I can't do anything with it. So that, for me, that was a big consideration.
So you can definitely spend a lot of time printing for your printer. Like you're printing parts for your printer, and it's like a snake eating its own tail. Like you're printing out upgrades for your own printer, and then you're like, I upgraded it, now what? And I was kind of running into that issue a little bit, where I was like, I really like to tinker with things, but at the end of the day, I just wanted to have my widgets come out of my 3D printer and have them high quality and have them to where I didn't have to paint them, which is why I have multiple colors, and didn't have to sand them as much, right? I wanted them to be high quality.
So, I mean, I guess, everyone might have their own different, purposes for a 3D printer, the different things that they have in mind they want to print with them. But Kate, what sort of things do you use your 3D printer to print?
I use mine to print a lot of, recently I've been printing jewelry, like this little floppy disk.
Oh, well, look at that.
earring
That's so
that I
cool.
designed.
It's the save icon.
Yep, it's the
Save icon. He
earring.
says. Oh my gosh. We all know that that's a zip drive.
Right. The things that I print are mostly decorative and a few practical things. Like here I have, for my retro computer hobby,
That looks like
this is a
SCSI.
SCSI SD, and this is a 5 1/4 inch drive bay adapter. And
Is
so
that an
this
old
drive bay adapter, which is the red thing? I didn't print this SCSI SD. Is something that you could go online, go on eBay, and buy a adapter that's ready made, that's made at ABS or aluminum or something. But to have the ability to print it out for a few cents in a couple hours of printing is pretty amazing.
Yeah.
You
I
actually
also
just
print
reminded
out
me of something, Kate.
little
Oh my
statues
gosh.
and stuff.
So,
Yes.
big into PC gaming over here. I just realized when you said that just now that 6 years ago I paid somebody on eBay to sell to me gaming computer fan grills that I would then paint the color that I wanted to have, and they're just plastic covers that go in between the screw and the fan. I just realized that this entire time I could have been printing those myself.
Yep.
So,
But yeah, a
so-
lot of practical, like some practical things like this. Let me pull it back. Is it screws onto the side of your
screw it on the
desk,
table. Yeah.
and then you put your laptop in it so that it sits on
Ah,
the side. So this is where I put my work laptop.
bit of a desk saver there. Yeah.
Yeah, so
Yeah,
that
I
because
see.
I keep my laptop in clamshell mode, so I just put my work laptop in there, so it doesn't take up desk space. And so there's things like that. Like you peruse these different websites that have 3D printed models, and you're like, this would be neat. And for my YouTube channel, I make these little Mackies, which is my
Mackie.
Macintosh character. He's my little AI sidekick in my channel, and being able to make little figurines of this character that's an imaginary character, or he's behind me, but to make little figurines to send to people is pretty cool.
Don't tell them it's imaginary.
It's not imaginary. It's to convert something from to model it in 3D, and it's in the computer. That's cool for videos and stuff, but to actually have it physically in person and be able to send it to people and have put on your desk and kids play with it is pretty cool.
Oh yeah.
So I use mine as, I don't know. I like to think of my 3D printer as almost like a sewing machine a little bit. Like it's a machine to do crafts, to build things, to kind of get my imagination going and to make that happen in the real world.
Yeah, no, that's fantastic. So I've got a quick question for you, Jay, because you did 3D print for a little while.
Mm-hmm.
Where did you go to find ready-made 3D models back in the day?
At the time, Thingiverse.com, I think it was, .org. I don't know. Thingiverse was the place to be, at least from what I heard. I would find something I liked, downloaded the STL, loaded it into my printer, and it would completely fail. But that was on my end. That wasn't the fault of the model that I got. But Thingiverse, there is a paid or a website that has paid options. I forgot the name for it at the moment. We can overlay it, or maybe one of you will remember.
Bling, yeah, it's appearing right now. For someone who's watching it right now, it's appearing on the screen right now. Bing.
And they have some higher end models that you could pay for. You could pay a few dollars to download it. And I used it a lot, like all the stuff on the pegboard there, all the bins, all the hooks, functional things like the workbenches that have one of those rubber feet missing. I would print them in TPU, and spacers, cogs, thumb screws. That's the kind of stuff I was mostly after. And I got it all from there. I only ever once designed something myself in Fusion. The rest, if you could think of it, Thingiverse would typically have it available. So that was my go-to. I know there's many of them, but I'm not too familiar with them.
Right.
Yeah. Yep. Sort of Kate and Eric, have the other sites that you would recommend, or?
The one that I've been using more recently is called Thangs, Thangs. And that is actually it's trying to be a search engine for 3D models. So it aggregates Thingiverse, Yegi, printables.com is also another one that I've been using, which is made by Prusa Research, who are essentially they made one of the first mass marketable low cost 3D printers, the Prusa Mark III or i3, I forget what it's called. But essentially that website, Thangs, kind of aggregates all these websites, and you can search for, I want a floppy disk model, and it'll bring up from all these different websites models of floppy disks, and then you can narrow it down between, do I want it to be printable? Do I want this to be a 3D model that I use in like a video game or something? It even has some of those, and then you can even take it down and modify it to make it printable.
Mm-hmm.
That's kind of what I've been using.
Yeah, excellent. So I guess the next progression, you've bought a 3D printer, you've grabbed all these things online, you've printed a whole bunch of stuff. The next step is you say, you know what, they don't have what I need, or they have something close to what I need, but it needs to be modified. And that's when we start then getting into the world of 3D modeling. Now, Eric, it's my understanding you've done quite a lot of this. So, what? I'll start this question first. First of all, had you done any form of 3D modeling before you started 3D printing?
My timeline is probably more unique. I had a friend in Ohio back home that was big into 3D printing, and 6 months ago, he asked me if I would be able to design something for him. I said, well, it's interesting. I've never tried, never thought about it. So I mistakenly went on Google and I searched something along the lines of free 3D design software or something similar. So the first thing that popped up, I tried. The name sounded harmless enough, so I downloaded and started playing with FreeCAD. To those of you out there who are unaware of FreeCAD, don't use it. It's
Glowing
not,
endorsement.
it's not for you. It is a phenomenal piece of software. I have the utmost respect for the creators of the FreeCAD software, the community that drives it, and it is incredibly powerful. And it's one of the only free CAM softwares out there for those of you who want to get into your different types of automatic routing and things of that nature. But we won't go there. FreeCAD is a three-dimensional version of AutoCAD. It is for people who understand drafting techniques. It is people who understand the different aspects of body to material design in the 3D space. It is not easy at all. It is a very terrible learning curve. It is free. And it does have the ability to open up step files, which is important. And it has the ability to export STL files, which is incredibly important as well. STL being a mesh file is the best terminology for it, because it's not the only mesh thing that you can print. So I would, and this is where this always goes, and it is, if you want easy, and you want to start creating your own, everybody agrees that Tinkercad is about the easiest, most painless way for you to go in, start clicking some buttons, start clicking some shapes, dragging some lines, and you can get yourself an STL. It's important to understand, however, that there's a stark dichotomy of two different concepts of three-dimensional design. There is mesh design, and then there's parametric design. Mesh design is... The way that I would explain mesh is you get a pile of clay. You have a big old pile of clay. That clay is very seldom perfect. It is
statues and stuff.
Yes, perfect. You have something that is physical. You have volumetric shape. That is not parametric. And while it could be made to be parametric, it shouldn't be. Parametric, or step files is what we usually call them, is quantifications of different polyagonal resources and multiple vertices and dimensions that span...
Like wireframe.
Yeah, imagine a dot matrix printer amplified into the third dimension. It is literally that. But it has the ability to embed different concepts,
Right.
like different groups, files, bodies, colors. You can include colors in step files now, for example, or 3MF files are wonderful. But that's where I'd really, if you're doing something that needs to be mathematically accurate, something that's mechanically relevant, you need to consider something like SolidWorks or the free version of SolidWorks. In my opinion, I call it the free version of SolidWorks. Is Autodesk has a software called Fusion 360 that you can download for free and utilize for free using the hobbyist license. That lasts for 3 years, and after 3 years, you must take your projects, export them onto your computer, and then renew your hobbyist license for another 3 years. It is, in my opinion, very user-friendly. I've heard the same from a lot of friends of mine that also design things in the 3D space. I've also heard the opposite of that. I've heard that Fusion is incredibly challenging, doesn't make any sense. In my opinion, it comes down to whether or not you have been given any type of hand-holding or training when you first start up. The concepts, none of these softwares are the same as asking somebody who's never used a computer to use Word. They'll understand quickly that you type the letter on the keyboard and it goes onto the white square on the page. That doesn't take a learning curve. But once you start extrapolating that into the relative dimensional space, and once you start applying that to symmetry, you have to understand some greater concepts. And those, in my opinion, are learnable. They're very obtainable. You can easily look up thousands and thousands and thousands of tutorial videos on YouTube. And I think that Fusion, having messed with all of these different softwares, I think that Fusion is the perfect blend of all of these different tools. And that is because it allows for what are referred to as coincidence. And coincidence are, you can designate in a very, very clicky, a very mouse way. You can say, I want this dot and that dot to coincident, meaning that they exist in the same space programmatically. You can say with logic very easily, this exists here and here to create that relative space. Whereas in the mesh world, in the Tinkercad world, that little imperfection or whatever, that little I thought this rounded face and this rounded face that both have a tunnel going through them were lined up. When you go to print that, you left that one little sliver out in the middle. When you went and printed that, the slicer said, "No, I found that, and those are two different pieces now." We're like, ah. So it's important to understand that if you want to just make a thing, if you want to make a nice, pretty model, hop on Tinkercad. It's fun. It's easy. You'll have a great time with it. If you want to make something that is a tool, I'd strongly urge you to be patient and learn Fusion.
Okay, interesting. I have a sort of slightly different situation. I use software that no one else uses. Some years ago, I used to work for like a design studio agency sort of thing, and they did a lot of product design. And so what they would do is they would come up with a label design. We would then 3D create a bottle or a container or a box or whatever the product is. Sometimes it was a bag. It might have been a bag of garden soil or something. And we would create a 3D model of that. And then we would surface it with the design concept. And then we would plug it into a pretend supermarket or whatever, and we would make these simulations of these products, and then we would send them to the places and say, here's our proposed design, here's what's going to look like on your product. And we did it for spray cans, lots of stuff. So I had existing experience in 3D modeling using a product called Lightwave made by a company called NewTek, and it's used probably more for film, video 3D type work, but it has two separate applications. It has a modeling application, and then it has a sort of a staging application where you put all things together, set up lights and everything like that. But I had a lot of experience with that modeler type application, and I'm still using that now to create the stuff that I create. I generally, when I'm needing to do all the stuff accurately with measurements and the right sizes and the right distances, I create a lot of the foundation stuff in Adobe Illustrator, a vector-based illustration application, but only in 2 dimensions. I then bring those into the modeler and then extrude them or lathe them, or what the Boolean subtraction. So in other words, you might have an object here and an object here. You put them together and you say, I want this object to eat out of this object. So where the two meet, they'll carve a hole out of it. And so, I do that sort of thing. So that's how I do a lot of mine.
I think that I want to touch on this because I felt really stupid a couple months ago. I didn't realize that the industry term extrude was an industry term. And as a novice, I did not know conceptually what that meant. Being that I am a more advanced 3D designer now, these things are common to me. But having heard some very basic terminology from some friends discussing things, I had so many different things clicking in my head. So I thought it would be beneficial, if we're talking about this in an introductory capacity, to talk about a couple of the terminologies there, because extrude wouldn't have meant anything to me 6 months ago. I would what's that guy talking about? Sure.
Yeah. Well, so I will. Did you want to? Do you want to field that one then? I'm happy to hand it over.
I would love to. And Kate, if you can if there's a thing that I say that you're like, wait a second, no. I didn't know that one either.
I know I've been
Please.
relatively quiet, but I wanted. I think that's a good idea, is to kind of cover the basics here.
Because I was afraid. I was afraid of the 3D modeling software. So when somebody said to me, "You need to draw a sketch on a plane and then extrude that sketch," I was like, "Those sounded like words." That was definitely English. Didn't know what they meant. And with Fusion, to understand what that means is paramount. And that concept just eluded me so much until I got to messing with it. And what it meant was, when you draw a sketch on a plane, it just means, if you think about a 3-dimensional object, a cube or a cylinder, and you say, I want to grow something out of this. So here's a rounded cylinder. I want to draw a sketch on the top of this jar that I'm holding. And that means that it takes away the 3-dimensional aspect of that jar, and it points you right at the top of it. And it says, okay, what do you want to do? And you say, I'm going to draw a little tiny circle. Okay, well, now you've got a circle on top of a face. You've drawn a sketch on a plane then. That's all it means. You've drawn a shape on a face, two-dimensionally. Then to extrude that conceptually means take that small circle and stick it out or push it in. What you do after that is another conversation topic. But if you want to extrude that circle, you've now taken that small circle and you've extended it out. I happen to have a bolt just nearby, so I grabbed a random bolt. And then you have a small cylinder sticking out of your large cylinder. You've now drawn a sketch on a plane and you've extruded it into a new body. Or you've joined it to your existing body and now you have a small cylinder on top of a large cylinder. That concept alone is how everybody should think about 3D design. Make a thing, create it into a new space. Now, you can always go into straight lines, and that's where you talk about more advanced techniques such as lofting or sweeping. And that doesn't need to be discussed today, but you don't always have to take a sketch and go out into a straight line. You can say, wait a second, I want to take my circle that I just drew. I don't want it in the center. I want it to hug this edge. Wherever I drag the circle, I want it to hug the edge, and then I want to extrude it there. You can tell it to do that. You can create that coincident. You can say, go follow this until I tell you to stop. Okay, now that you're here, unlock it. Let me resize it. Okay, I want you to come out this far, but wait a second. I don't want you to come out straight. I want you to come out with a 5-degree taper or something like that. So think of it as there's absolutely a method. There's absolutely a tool for whatever your goal is. Look for it. Don't just take the quick solution. Don't take the hammer solution. There's always going to be like a really cool, nuanced way. And don't settle for less because it's actually there. I promise.
Well, this is an example which this even works with it. So this is my vodka. No, I'm only joking. So this is looking at a shape like this, and if I was wanting to recreate this in 3D space, if we look at this from this angle and we were to take a point from the center and trace a line out and then down and follow the contour of this as a single line and then into the middle there, and then you were to take that and you have an axis down the center of it and you rotate it around that center axis like a lathe, like as if you were lathing some timber, you could then create this shape very, very simply. To create this shape, all you need to know is this shape around the outside and then wrap that around 360 degrees until you have a shape like that.
But therein lies the beauty of CAD. There's so many ways to do what you just said. You described one of them. And this is my word of encouragement to all of your viewers and all of your listeners. If there's a way that you can think to do a thing, it can't be wrong if you can do it. There are so many different ways to achieve the exact same thing that he just described. I can think of 5 right off the top of my head. If that bottle that he held up, I can think of 5 different ways that we can recreate that fusion, and every single one of them is right. So if you can do it, it's okay. You don't have to do it somebody else's way. Don't feel like you're breaking the rules. Like when you were in high school and the math teacher said you got to learn this process. Sometimes, and this is the best advice I could ever give somebody in 3D design, Google or YouTube the thing you want to learn and mute the audio. Watch somebody else click around. Watch somebody else get somewhere. Watch somebody show you a menu you didn't know existed. Fast forward to the end of it and see if somebody actually created the thing that you wanted to create, and then go to the beginning and see if they started where you are. Maybe their method's different, but maybe they'll show you the way accidentally. And maybe their thing doesn't perfectly pertain to your thing. So don't necessarily think of being able to be wrong. There's just many ways to be right.
Okay, fair enough. That's some nice solid advice there.
Can I add something about the software?
Yeah.
And I don't exactly know where we are in the questions because I'm just sitting here. Oh, this is interesting. Keep talking. I am, out of the 5 of us here, and I say this with confidence, you can challenge me if you want, but you'll lose. I am the most impatient person here right now. I guarantee it.
Yeah.
I ordered the printer. I got excited, watched hours of YouTube. Yeah, let's do it. Then when I wanted to design my first thing, and it was a spacer for something. It was stupid simple. But when it came to the software, it all fell apart for me. I didn't have the patience to learn it. I would watch a video. Someone made a video 2 weeks ago. Oh, that's how you do it. Go back to Fusion, which in 2 weeks already advanced 500 versions, so that button is no longer there, and that feature is now called something different. And it was incredibly frustrating for me to learn the 3D software and trying to figure it out. And then this prick in Australia buys a printer. Oh, I'm using multi-million-dollar Hollywood software to create a spacer for something. Let's do it. And I'm sitting here struggling like crazy. So patience is incredibly important. And when you're ready to give up, don't. Because once you learn how to do it, it is so worth it. Don't get discouraged.
Yeah. I mean,
Phone a friend. Phone a friend.
Yeah.
That's how all of my community works is you call somebody, you ask somebody, you screen share with somebody. Somebody out there knows. Somebody knows and has been through it already. Go get involved in Reddit. Go get involved in Discords. Talk to people.
Yeah,
you don't
there are
have
great
to stick to
communities out
monolithic
there,
YouTube
for sure.
videos.
Yeah. Well, I mean, we'll be touching on this sort of later on, but I mean, I have a circular saw, and it has this little tube that sticks onto a little tube for sucking out the sawdust, and it attaches onto a little thing. And the original thing that was made for it was just really poorly designed, and it broke quite quickly. And to be able to not just replace that item with something that I designed and 3D printed, but to redesign it in a way where it's not going to break in the future, it doesn't have the same weakness that the original one did, is an incredibly rewarding thing. That I haven't only replaced the original item, the one that I've put in there is better than the original. And that is a really, really rewarding part of doing your own design with 3D printing. Now, I'm going to jump across here to another question. We are delving more into the technical stuff here, so I do apologize if you're watching this and getting, sort of finding this all a little bit tedious. But we have, within 3D printing, we've just talked about the idea of going in and designing and modeling these things. And so we now have our 3D model. We can see it on screen. We can spin it around and look at it from different views. And we can go and save that as a file, whatever that file potentially might be. And inside that file is a whole bunch of numbers and coordinates and stuff like that, saving the information about our 3D object. Now, I've got that file. I want to print to a 3D printer. Now, the file I've got is in the very commonly known STL file format, we'll say, just for argument's sake. And I go to get that STL file and send it to my printer, and I find out, no, the printer doesn't take STL files. It takes a file format called G-code. So I have got this chasm here now of this STL file that I've just made in my 3D software and the G-code file that I need to send to my printer. How do I get from A to B? Who would like to field this question?
I think that we both have two very unique perspectives on this. I think I'd like to take the simple one for the Ender 3 beginner, and I'd like to sit back and learn from Kate about the process for the bamboo, because it is magic, witchcraft even.
It's similar process though. It's all the same slicer.
It is, but I'm gonna take the steering wheel a little bit, and when I hand it over to you, can I ask you to talk about the multiple color aspect?
Yeah, that'd be great.
Thank you. Okay, so to bridge the chasm, as you so eloquently put it, is you can open up any number of slicing softwares. I prefer Cura, though there are many different slicers out there. Prusa Slicer, Super Slicer, many out there. The simplest way is to open up Cura, tell it what type of printer you have. It pulls down a profile off the internet to make sure that it's going to create G-code that is appropriate for your printer. And then you just change the orientation of the model on the build plate. Once you've opened up your STL file, you can make sure it's upright on its side, whatever makes sense for your layers to print in. And you enable something called supports. You enable something called build plate adhesion. You enable something called infill percentage. You can do so many different things. I could sit here. We could talk for hours on what you can do in Cura slicers. But that's not important. Is it going to fall over when you create these layers? You're going to print something. If you're going to print a human body that's standing upright, you can do that, but it can't print the hands up in space. It has to start from the bottom. So that's called supports. And you do this in the slicer. You say, yeah, turn on supports for this percentage of an angle or this degree of an angle, this much overhang. degrees, what they use. And then you have to ask yourself, how strong do I want it to be? So that's when you have something called infill. You do 100% for very strong things. You do 5% for things that will technically stand up, but you could probably squeeze them and break them if they're PLA. Then you talk about infill patterns, because maybe you don't want to print an entire spool of, let's say you wanted to print a basketball. You don't want to waste an entire kilogram spool on a solid basketball model. You want to make that thing strong enough to throw across the room and not break into a million pieces, but you want it to also not burn up a hole in your pocket every time you want a toy. So you can look at different things. I prefer cubic subdivision as an infill pattern, which is coalescing squares that look at the exterior walls. You can get bigger on the interior and smaller on the exterior, and they go angled X and Y. That way you never have a layer that is just solid on top of itself. It's got an angle. So that way you can fill it with air, but you can also fill it with material that is going in multiple directions. The last thing I want to touch on real quick is something called build plate adhesion. For those of us out there with no touch sensor or a basic BL touch or a CR touch bed sensor, you want to establish either a brim line all the way around the outside, which creates a nice flat, just plate of material touching. That way when it goes to start printing, obviously it's hot and your room might be cold. The regular effect of hot meets cold is contract. So it'll start peeling up and warping up off the build plate. So if you have that very, very large heated build plate and large brim that's keeping it nice and warm, it'll keep that print held down. And some people even use purple glue stick to hold that down. So that build plate adhesion is important to understand. And then what you do is once you have that thing sliced and ready, you know that it's going to work in the printer. You hit export, gives you a G-code file, throw it on an SD card, pop it in the printer, select the file, and hit print. And that G-code controls your nozzle temperature, your print speeds, your bed temperature, your support speeds, the thickness, the thinness, the layer height, and how thick or thin or dense you want the model to be. That G-code does all of it. That is a simple thing for Ender 3. Jay.
So the way you're saying it, and am I to understand that basically you're translating a 3D model to a programming language that tells the printer exactly what to do?
It's not even a programming language. It's text. I don't know if you guys know this. You can open up a G-code in Notepad right now and see all the different pieces. And it's one row at a time is an action. It's X, Y, Z position, extrusion amount, speed, next instruction. That's it. They're all in text. And it's very human readable text too. There's a couple different codes in there that say like home or relative space up down or retract filament, things like that. But no, it's very simple coordinates. You can look at it, and then those G codes. Like if we all three of us, I know that Jay, Bruce, and I all three have Ender 3 V2s. I could give you a G code and you could plug it into your printer. You could go grab that same STL and slice it yourself, but if my G code works, I could share my G code with you, and you could print it and know that it worked for me.
Yep.
Now, Kate, I would love for you to take this over from a Bamboo perspective. I want to be quiet and I want to listen about
So the
all the
slicer,
different things.
the concept of the slicer is the same for the Bamboo 3D printer, right? It's the slicer essentially is taking the 3D model and doing literally just that, slicing it into the layers that the printer is going to do. The Bamboo slicer is called Bamboo Studio. And if I could share my screen real quick, if that's possible.
Absolutely.
So this is the Bamboo Studios. This is a slicer. It's actually a modified version of the Prusa slicer that Prusa printers use. So that's an open source slicer. Similar to Kira, how it's an open source slicer that's free and available to everyone to use. So this is a STL. I downloaded it from the internet. It is the bust of Helios. And for the thing that's special about the Bamboo Lab X1 Carbon, at least the one I have, is that it has the ability to print multiple colors. If you have this AMS system that sits on top of the printer, you can print 4 colors, and if you have multiple AMS systems, theoretically, you could print up to 16 colors.
Wow.
And you can actually get models that are, you can color them yourself. It's not too hard. There's actually a color painting tool that you can use. And let's just say I want the base to be black. So what I can do is get this tool, and I can just start painting directly on the model itself. So let me get
Now,
the...
this is pretty fancy software. Can you give Helios a nose?
That is something I cannot do, but I can.
Okay.
Let's just say I wanted to, draw a design on him. This
Give
is
him an eye
very
patch.
bad, but I have different colors here. Let's say I want his face to be green or something, so I can sketch it in like that. And I want the base to be tan. I can even use like the fill tool, for instance. That's probably what we want.
Oh, okay. So it's in that one. It
Fill
just
it in.
feels. It automatically knew to just do that flat plane and stop when an edge came along.
Which is something that I found useful. For instance, when I made my earrings, these were actually single color models that I then colored in using that tool.
Wow.
And so essentially, what the slicer does is it pulls in the color. It knows what colors you have in the printer, because when you install the roll in the AMS, I'd say, okay, this is a green filament, this is red. And then it'll send that to the slicer, and so the colors will match relatively. So I can make sure that I have the right colors for the object that I'm printing. And what the bamboo will do,
Go
ahead.
ahead.
Oh, I was going to say what the bamboo does is it has a little blade at the extruder. So inside there's a tiny little blade, and what it does is when it's finished with one color, it'll cut the filament and pull back that particular, let's say it was red, and we're pulling back the red, and now we're going to put in black, and then it'll pull back the black roll and feed it into the extruder, and that goes out the back of the chute. There's like a little chute in the back that'll release the leftover red so I can start printing in black. So that's what it does, each color change.
It has like a reservoir, or has somewhere where all of this, because you're going to have a certain amount of filament inside the hot end part, the part that gets hot.
Right.
It has to be squeezed out. It's got to push that out.
Purge.
And, purge is a great word.
Purge tower is actually the terminology.
So, for bamboo, purge towers are actually optional, because you can there's a little chute out the back, and some people call it it poops out the back, but essentially it's a little open area in the back where it will actually purge, not in the print bed area, but it'll eject it out the back.
And so we'll just put a little, waste.
It's like a little curly cue of excess, and you put a little basket back there to catch
that's cool.
excess. They're little pigtails. But for instance, in these earrings that I print out in pink, you can see this right here. This is the purge tower. So that it's short because it's only as tall as your models are high.
Okay.
But essentially, what it does is, let's say,
blow her screen up there, Bruce.
What have I done?
Just
sorry.
Make it full screen.
Nothing wrong with me. I'm too interested.
Okay.
There we go. Yep.
So essentially what we have here is these are the models, and this is the purge tower. So it's only as tall as the models are high, but you can see that I was printing in, it's probably hard to see on this camera, but it's gray, pink, and a little bit of blue inside the Mac.
That's so
cool.
cool.
What it's doing is it's kind of squeezing out the excess. So like, let's say it was done with pink and now it's going on to gray. It's going to kind of push the excess pink that was in the nozzle onto here and then keep printing the next color.
It's almost like an artist going and cleaning his brush before
Exactly.
starting something else.
And there's even ways to, because all this is waste. Like this little block right here is not useful for anything. So there are ways that in the slicer, and the slicer is actually the 3D printer isn't necessarily smart. The slicer is where all the brains are, right? That's where you're doing all your optimizations and telling it, okay, I want to, instead of wiping on this tower, I want it to go out the back of the printer, or I can even go in the infill. So Eric earlier was talking about the infill. That's kind of makes the
it's
model,
inside the model, so it's not going to be seen.
Yeah, so you can put your, let's say I was printing black and white, I can put the the other color inside so that it's not visible,
Yeah.
which
Yeah,
works
no.
for some models. If you have a more transparent filament, it may not be what you want. So that's an option, right? There's all these different options.
There's
And so
actually
this-
another really cool aspect I wanted to touch on real quick is you can poop it out the back, you can purge tower it, you can infill it, or, and I've had a friend show me this just yesterday, and it was the coolest thing. You can print your model and say that you want to have no purge whatsoever, and you can tell it to continue printing as if a purge happened, and you can actually cause it to transition mid-layer intentionally. So you can tell it just keep printing. I don't care about the color continuity. And if you switch enough times, it creates this really cool effect of a mid-layer transition. So on angles, you can start seeing these color bleeds, and it looks totally wild.
Yeah, I was going to say that would look kind of funky, I would imagine. Yeah. Now, we talked about, with the slicer, you have this stuff with the infill. The one that you're using there, Kate, that has the same sort of things. You can set the infill, the amount of infill, the type of infill, all the same sorts of
Exactly.
things in that software. Yep. Okay.
Yes, all the settings are the same. The special thing about the Bamboo Studio and a lot of slicers that are that are kind of paired with printers will have settings that are optimized for your particular printer. So that's the benefit of getting one of these, higher end printers that are paired with the slicer, like a Prusa or the Bamboo, is that you don't have to fiddle as much with the settings because, you have, essentially it's like printing out on a regular 2D printer. You can say, I want this draft mode, and it'll print using less ink, and it'll be kind of fast and blurry. Or you can print it out in fine mode. And for a 3D printer, that means the layers are going to be thinner. And so you're going to see the layers a lot less. You can get a little bit more detail in your print. And all those presets are built into this particular Bamboo slicer.
Oh, we've talked a little bit here about designing stuff in, sort of these, 3D, illustration packages, that sort of thing. But let's say I'm in a situation where I have an object. I don't know. Here's an object. And let's say I don't want to necessarily go through and design this. I want to just replicate this. I want to do what they do in the movie industry, where they sculpt those maquette sort of models and then they scan them and they bring them into the software from an actual scan, a 3D scan. Is this something that can be done with 3D printers? Can I take an object, scan it, and essentially turn my 3D printer into a 3D photocopier? Am I talking science fiction, or am I talking a realistic thing here?
Yes, you can. There's several ways to do this. You can spend $800 to $10,000 on a 3D scanner. It is exactly what you think it is. It's a small little plate where you put an object, and it either revolves or the camera around it revolves. And it just uses a technology called LiDAR, which is audio waves and reciprocation of sound, to understand where something is in conjunction with visual. So it maps sound and visual to a distance that allows you to then understand where an object is. It doesn't do a perfect job. You have to mess with the tolerances, but then you can use that in a software like CAD as a stencil. If you take, I love that I have this candle here because it's this perfect little cylinder. If you were to throw this in a 3D scanner, you could say, all right, well, I know in my head right now that this isn't perfectly flat, but I can take my handy dandy calipers and I can say, oh, this is exactly, 22 millimeters in diameter. Okay, well, let me go apply this circle. Let me go take this 3D scan. Let me take this mesh of polygons and weirdness that I got from my 3D scanner, and let's expand it up into this circle. And then I'll start tracing things like the screw on the top of the jar. I'll start measuring the gap of the lid to the rest of the body. I'll start understanding the taper of where the feet of the jar are. So yeah, you can easily scan it. It'll give you a mesh. You can easily scan it. You can go reprint it. It'll be fairly accurate too. But you don't have to spend that kind of money to do it. The most recent iPhone actually has LiDAR built into it. So you can just go on to Amazon. You can buy a carousel. You can put an item inside of something in a well-lit area without any crazy amounts of background. And you can revolve your iPhone around it, and you can take a 3D model using LiDAR and the camera and you can actually 3D scan something today, right now, with your latest iPhone. And you can, again, import a mesh, or if you want to import that mesh into CAD, you can then trace it and you can create that model as well. It's then up to you to create finer details and textures and colors.
Yeah. There's actually, if you're a Windows user, there is actually a built-in 3D scanning software in Windows that if you have an Xbox 360 Connect, maybe it's a 360 Xbox. If you have a Connect, you can use it to scan objects. It's not the most high resolution, but considering that Connects you can find on eBay relatively cheap.
You're the Macintosh librarian, though.
I use all computers
Sorry.
to get the work done. But that was something I found kind of neat. But of course, like you said, Eric, iPhones are definitely a lot better now than the Connect was. The 2012 Connect.
I didn't know that
then.
they actually do it. That's really cool.
Yeah. So
What's the tool called? Is it built into Microsoft, or is it just?
It is built in. I don't
what's
have
it
a Windows
called?
machine in front of me. So
Okay, well, at least you redeemed yourself there. You're not on a Windows machine right now.
Right.
Somebody will put it in the comments, I'm sure.
Cool.
But it's photogrammetry software for your iPhone. I can't think of one on the top of my head. I think Metashape is one that I've seen. Agisoft Metashape is a pay software that you can essentially take a bunch of pictures. It could even be like your car or like a statue out in public or a building even with the drone. And you can, the software will look at all these pictures and automatically come up with the math and try to estimate, the size, roughly the size of the object. Like one thing that is always a struggle is, let's say we want to replicate a classic computer using scans. That level of detail kind of gets into more of the parametric side of things. That's like what Eric was talking about. So like if you're trying to scan something that has a physical use where, these two bolt holes have to be 100 millimeters apart with a certain depth and a certain gauge, that's going to be impossible without a lot of work. But scanning something like a statue
behind her, that bust,
Yeah.
impossible to do in parametric.
right?
Yeah. Well,
But a scan
yeah.
and cleaning it up is something you can easily do with,
Many years ago, I'm going to say probably maybe 15 or more years ago, I played around with a little homemade 3D scanner, and it worked by using a laser line, a turntable, taking a whole series of photographs, and then it would analyze those lines and then create a mesh from the end product. And when demonstrating that, it always worked really well with busts. If you had a little bust of something and then you went and you did a scan of it, the end result was like, oh, wow, look at that. Look at the way that's scanned in that 3D. If you were to try and do the same thing with something that was more geometric, the end result might be a little bit warped, a little bit wonky, didn't look as good. That's an interesting point. And of course, if we talk about, because this is something that us vintage Mac users are very interested in, is that idea of potentially maybe scanning or reproducing plastics, maybe parts sort of broken bezels, things that are cracked. But of course, one of the problems we have with things like these old computers is a lot of them have very, very fine microtextures on them. So even though we might have that shape scanned into a computer and we can look at the model and go, isn't that nice? When you go and print it, it's not going to match up with the original, even if you're using the same colored filament or even if you spray painted or something like that. Because if you go up and have a look closely, you'll see that the original plastic, which was molded, has an incredibly fine microtexture on the surface, which you are going to struggle with given the resolution of some of these, end users 3D printers. So just thought I'd throw that in there. Now, as far as 3D scanners go, I'll just mention a couple of these. If people are interested, these are ones that I have not used, but I've seen, seen some of the end results from. There's one called a Revo Point Pop 2. 3D scanner. I've seen some of the results of those, and they look pretty amazing. And of course, Creality. We've talked about Creality's 3D printers. They also make a little handheld 3D scanner, and these are, considering that these used to be the sort of items where if you wanted to buy one, you'd visit the website and it would say, "Call us for a price," because it was going to be, they wanted to make sure that you were sitting down. These days, these are consumer level products that can be bought, sort of just by people, sort of who, want to tinker around with them. They're not something that only a business would have to buy. So just wanted to mention a couple of those 3D scanners that are out there as well.
I did want to touch on one single troubleshooting thing, and it's just a word of advice. If you are going to get the cheap printer, if you're going to get the one with no auto leveling whatsoever, please don't be afraid while you're printing, while it's starting. Don't be afraid to adjust the knobs while it's printing live. Get that first layer squish. Don't be afraid to touch it while it's going. I used to do for a very small model, I do hilariously large brims so I could keep dialing it in and then yank it off and then keep dialing it in and then yank it off again, because it eventually get down to where you're actually going to start printing and it's just perfect.
I've never even thought of that. So we're basically talking, as you're printing a brim, it's going outside in, and you're watching it as it's printing. And then you go, "Oh no, that's not right. I'm going to change this corner or something." You make a little adjustment, and you just tear off what it's printed thus far.
Yeah.
I've never even thought of that.
I've used like the little snips to kind of grab the filament and like pull it out right when it's going. But yeah, I do the same thing, Eric. I don't know, in the Marlin firmware, the last time I used it, had a setting called baby stepping, where you could even do minute steps in the X or Z axis while it's doing its first few layers, just so that like you notice that, it's a little too low and you're smushing your nozzle against the bed. Well, you can pick it up ever so slightly and that will save your print, right? Like the first layer is where is the foundation of everything. So you have to make sure.
Yeah.
My cheat was, if you've cracked open the speed menu in Cura and you've opened up every option, everything has its own little speed setting if you want to. So my little hack was, even today, even with the nicest stuff that I can put together, I still prefer to run about a 20-ish millimeter per second initial layer. That way I get that really nice, slow, smooth squish. But back when you're doing manual stuff and you're doing that little trick that I told you about, where you're just on the fly wheel adjusting, and then pulling the brim off, you can go to your brim and you can say, make the brim like 30 or 40 millimeters per second and make it huge. Or you can make it incredibly small and make it go even slower than your initial layer. That way you can say, I don't want to waste a lot of filament. I want it to go around the model 10 times. So we'll do 10 external runs around the model, and you can count the times it's going around in this big circle. It's all eventually going to be some degree of circle. And you can say, all right, I've got this many rotations to mess with it and keep pulling it off and mess with it. You don't have to pull it off. It's just cleaner if you end up like really borking it. But if it gets to that 10th rotation, you still don't like what you've got, then just hit cancel and you just start the exact same print again, knowing that you've just started right there. So you don't have to constantly go back to the slicer and change this and change that and whatever. You can just try it a couple more times. Just simply watching it go all the way around that many times, you can get it there.
I'm going to just quickly mention a term that when I very first started doing the 3D printing, that used to turn up in all of the the community groups, and that was first layer porn, where people refer to, sitting there staring at a first layer printing on the printer. I don't know who coined the term. It wasn't me. I'm only quoting, so don't shoot the messenger. But I remember seeing a lot of people refer to this as, hey, have a look at this first layer, man. It's awesome. It's like these weird things happen to people when they get into 3D printing. I don't know.
Because all the work that it takes to get that bed leveled right. If you finally get the ability to print your whole bed, like 300 by 300 millimeters for a CR10.
Mm.
When it's perfect all around, that's like the perfect bed level, and that is awesome to get.
Because
I don't have to care. On the other hand, on the other side of that, I can go twist my screws right now, run a print, and have it work perfect. Like I don't even have to care, because I set up Mainsail on a Raspberry Pi, and I run the Clipper firmware, and I set up my own custom bed leveling mesh touch sensor that goes before every single print and stores to a temporary profile. So if I inadvertently yanked a gigantic print off that was like super stuck to the bed and I messed it all up, I don't have to care. I don't have to try again. I just throw another print at it, and it goes around and it touches everything again, and it makes a brand new mesh, what's called a height map. And that new height map is then applied to the G code on the fly.
Now, the only thing I would say about that, and correct me if I'm wrong with this, Eric, but the only thing I would say about that is when it comes to the printer making its compensation for that, it does have a limit to the precision that it can adjust to, as in, and that precision is based on the steps of the motor that is driving the Z axis, it going up and down. That it can only that it does have I guess would say a resolution, a limit to the resolution of adjustment it can make.
Sort of. So if we want to get technical, the term here is logarithmic delta. Is this the correct terminology here? So in that height map, if you think of it like, imagine you have 1, 2, 3, 4 points, and each one of those was a touch sensor point, and you want to print something perfectly here in the middle. Well, you only touched here, here, and here, and here. So what it does is it performs a logarithmic delta that says, hey, from this axis in to this axis in on the bottom, how much difference is there? And it creates a sweeping delta of those. Then it does the same thing for those 2 points to up here and creates a sweeping delta between those. Same for the top 2 points together. Another triangular logarithmic delta. That logarithmic delta then allows it to apply, so long as you have a glass build plate or the magnetic PEI sheet attached to a steel plate, which is what I'm hoping most people do, you're going to have less variance in those than what you're going to get out of, I think the best that this is really supposed to be doing is like a 0.2 millimeter diameter nozzle. So long as you're at least using something with that, what I would call large of a resolution. The 15 by 15 touch point Cartesian that I'm using on my Ender 5 Plus, which is a 350 by 350 by 400 build volume, I don't have the ability to mess it up. And I did this intentionally once. So I replaced my bed springs with the silicone standoffs, and I took my calipers and I measured them all to an exact perfect 14 millimeters gap from all 4 corners of the actual build plate to the mounting brackets for the 2 Z-poles. And then I intentionally lowered the fronts down to 5, and then I lifted the fronts up to 6, the backs up to 16. So it's just absurd, right? It didn't matter. It didn't matter. And that's we're now talking about a 12 millimeter difference from back to front, which is absurd. Yeah. So long as the head wasn't crashing into the glass, all it had to do was it had to compensate. Now, I did have an extreme under. However, this is the fun part. As long as you are rafting and you are telling it to print an imperfect medium between the glass and your print, it's just going to continue printing. So you'll eat into the model on the bottom. So you'll have to have like kind of a standoff. But I wanted to see what it would do. And all it did was it printed the entire bottom askew and then started lifting it up from there. It was pretty wild. So yeah, it does have limits, but as long as that the glass is flat or the metal's flat, it's gonna compensate. And if you can eyeball it, it says, yeah, it looks kind of flat, it will do the job. As long as you have enough of a grid.
Do you run into any trouble getting that raft off the bottom of your model?
I don't, and I don't know if this is good advice or bad advice. Kate, you've been here longer. You have the tribal knowledge to tell me if this is bad or not. So please do. I had a buddy suggest that I stop using the Ender glass beds anti-stick side and flip it over and use just the smooth glass that you would just get at a hardware store side of it. And I've done that, and it creates what I would call a mirror finish. And it does. And because of that, I have a tall pedestal fan that sits over here that when a print finishes, I turn that on high and let it sit for like 5, 10, 15 minutes. I go over and I pluck it up like it was sitting on a table. I've never
so I was thinking more about the fact that your raft is joined to the model, that you have to separate
separating
those
the
two
raft.
things.
Oh, okay.
Yeah.
All right. Sorry. Well, before I do answer that, Kate, did you have any opinions on the flipped build plate?
The shiny side.
I'm a fan of PEI, which I'm not sure what that term means, but essentially it's a piece of plastic that gets tacky when it's warm, and then when it gets cool, it releases the model. I do have issues with rafts, messing up the model and stuff, like on this.
I've been there.
It mucks it up. So
Yeah.
with the either use PEI, which is polythermide sheets, or the awesome thing about the Bamboo, if you get your printer perfect, and the Bamboo is perfectly level, you don't need a raft or you don't need a brim. It just prints the object, and that's it.
Yeah.
Mm-hmm.
So that's as clean as you can get it.
Before I
Cuts down on
got the bed leveler,
time.
I had that classic dip in the glass, and I had my glass was completely messed up, and flipping it over and using the mirror side fixed a lot of the issues for me.
The mirror side's totally fine to use.
Yeah. I had I just wanted to do a quick little. Sorry, Eric. I know you're busting to show me that stuff. This will be very, very quick. I promise you. The one little product which I use regularly on mine, and I can't remember the name, but someone will probably be able to remember it. It is like a glue stick, but it is actually specifically made for 3D printing. And you stick the stuff on, and it's, as Kate describes there, it's tacky when it's hot. But when it cools, it's not sticky, and I found it to be perfect. So that when you print, your model is stuck on there and it ain't coming off. But as soon as the bed cools, it just comes off nice and easily. Yes. So, Eric, sorry,
I want to better answer your question, and using science, I cannot. I cannot, and it's a fact. So what I have here is I have a plastic plate. Polymer plates. It's just regular PLA. Because I'm arrogant, I wanted to try to print it on my Ender 3 instead of flat on my Ender 5 Plus. This prints perfectly flatly on my Ender 5 Plus. It's phenomenal. But I wanted to see if I could, because we call them bed slingers, because they sling the bed back and forth and make it incredibly challenging to have really nice, clean prints. So I wanted to slow it way down. I run it typically pretty fast. So I have it like dialed in the way I like it. I ran this at 75% my normal speed. So like I was really just dragging along. But in order to get this to keep from falling, or to get it to fit, I had to print vertically and diagonally. So it's like not at all desired. It ended up, you can kind of see it warped a little bit. It's functional, but it's whatever. But in order to keep it from falling, because I had a couple other people try to print this piece of plastic and they said I couldn't do it on my Ender 3. I'm like, you got to raft it. You got to raft it huge. And this is the raft from it, actually. And I don't want to pretend to understand this, because it printed like this. It has these little teeny tiny tree supports that went into that hole. But basically, the strength of it holding onto the build plate prevented it from falling over from the sides. But here's the interesting part. Now, hopefully my camera can capture this detail. If I hold this up and I try to reflect the light off of it, you really can't see where it was sitting. You can't. I'm trying to catch. I mean,
I can see it, but
smooth.
Yeah.
But here's the interesting part. Here's where it sat. This was the bottom, and you can kind of see that it sat there, but you can't see any discernible connection between the two of them. It's not. It's not some weird break or anything like that. And it was the most cathartic and therapeutic thing ever to take this thing off and go, okay. So I'm now a very
never works like
believer.
that for me.
I've had some rafts be challenging. It comes down to whether or not you are applying then additional supports into it. that was my experience. So I made a standoff. This is just a regular equipment mounting standoff that I also rafted. I don't think I have the raft handy. I don't have the raft handy because I had to deconstruct the raft piece by piece.
Okay. Yeah.
So
yeah.
it had supports. It printed in this orientation, and it had supports going up through it that attached to the raft.
Okay.
So that raft was then incredibly easy to tear off the sides. Once it came to these inner pieces, it was like every other standard supported print. It was not easy.
Okay.
But
Excellent.
but it is very helpful for bridging the gap between an imperfect bed and a nice print medium.
Yeah, I have to confess I haven't done a lot of rafting with the prints that I do, but I do definitely appreciate the value when you have that sort of situation going on. Now I want to just quickly.
Sorry, I just went upstairs to say goodnight to my wife and kid, and she's like, "What are you guys talking about? 3D printing? We have 2 guests, and we're talking about." It's like, "Oh, can you turn on the printer in the basement? Because for Valentine's Day, I want to print some jewelry for one of my girlfriends." No. I mean, it's gonna take me weeks
That's
to
a
set
good
it up and
incentive.
to relearn everything. So
It's coming
then
from
I'll do
everywhere.
it. So, okay, I'll plug it in. I'll turn it on. You do it. So that's going to be fun.
Okay, so the next question. We are getting close to the end here, folks. So don't worry. I'm sure you've all got other things to do. Now, we touched on a little bit earlier, obviously, that these printers print in layers, and we talked about the fact that the way you print something can impact on the rigidity of something based on where those layers are, whether they impact it structurally. But there is another thing as well, and that is that anyone, even if you don't have a 3D printer, but you have seen something that has been 3D printed, you will invariably have seen the little tiny lines down the side of what is being printed. Now, of course, there are plenty of ways, there are methods that you can use to maybe reduce that. The better quality printer you have, the less likely you are going to see those lines. But really, if we're talking about a lot of these entry-level printers that a lot of people have, you are going to see those lines. Is there a way of getting rid of those lines?
If there is, please tell me, because I'm dying.
There is a brand of PLA that is out there that I found to be relatively easy to use because it actually melts with alcohol. Is Polysmooth by Polymaker. I'm not sponsored by Polymaker, even though they're my favorite brand of filament for making little figures and stuff because they make a really good matte filament. But that allows you to use alcohol to smooth down. Essentially, the alcohol will react with the plastic and melt down the lines on the side of the print.
So you will be sacrificing, I guess, a little bit of detail there because you're ultimately smoothing it down, aren't you? Yeah.
Exactly. It is I guess I'm thinking about it like in terms of compression. It's kind of a lossy thing to do to the object, right? It's you're not going to, if it's a perfect parametric thing, you're going to lose some perfections there. I know, Eric, what do you usually use
for the removal of imperfections on the exterior? So I'm supposed to sit here and I'm supposed to preach to everybody the quote unquote right way. And the quote unquote right way, and I don't like it because it's really annoying and I'm impatient. And I don't do it. Let me be very clear, I don't do it. The right way would be to sit here and spend hour upon hour upon hour calibrating your printer. It is not fun. It is actually quite the opposite of fun. It's actually quite infuriating because you're likely to fail a single print during calibration several times before that one calibration prints successfully to where you can make an adjustment for your next rerun of that same one again. I do not have the patience for that. That said, I cannot sing the praises of running Mainsail on a Pi and running the Klipper firmware enough. I say that because it has the ability to do what's called input shaping. And input shaping is the way of the future. Input shaping is adding a small USB charged and interfaced accelerometer on your bed. And that accelerometer feeds into it and explains to the Raspberry Pi specifically mainsail, the different imperfections of bed movement or head movement. If you have a core XY, or if you have a top-down Z like I do, you won't use an accelerometer and input shaping on the bed like you would with a bed slinger. But that input shaping allows you to have a vibratory response variable that allows it to say, hey, up at this high, you're going to have this much imperfection. Down at this low, you're going to have this much imperfection. So it does two really cool things. One is it accounts for those imperfections at whatever speed you're running, and says, hey, here we're getting this much response, adjust this much movement. At the same time, because it has the ability to do that, you can crank your speeds like double and triple what I was talking about earlier, because most of your issues have to do with the imperfect nature of the flexibility of your rubber feet, the flexibility of the poles holding your gantry together, the flexibility of the bands that move the different motors together. All of those are imperfect. They're not chain driven. They're rubber belt driven. So that with that imperfection, you can accommodate for that swivel, that delta, and you can tell it, hey, you've got this much imperfection, so only put material in between there. Increase the extrusion rate, decrease the amount of movement that you're doing to get there, and fill it. So you can actually remove a large portion of your Z banding, which is what most of those layer lines are. It's called Z banding. When you go to the next layer, you see that weird little shift. You can also get rid of a lot of warp, because that's usually due to material being put somewhere inappropriately. And you have the ability to say, hey, go 3 or 4 times the speed, rattle this printer apart. And you start looking into things like bracer bars, like those big triangular bars that hold it down. And you start getting into situations where people get those gigantic, Dana, help me out here. The thing, ratchet straps, like for in the bed of a truck. You take ratchet straps. People are taking their printers, mounting them upside down on their shelves, and they're ratchet strapping them upwards. So that way they can run them ultra fast, work against rather than with gravity, so that way they're only pushing where they're supposed to reduce the amount of retraction that you have to apply. Then you have the ability to shake it like crazy, knowing that all of your vibratory responses are top down, coalescing with gravity rather than working against it upwards. So you get the fastest, most prettiest prints from taking a truck ratchet strap and strapping your printer upside down and printing it against gravity. It's the coolest thing, and it's crazy, but it works. It works, and you can get these little accelerometers for like $8 on Alibaba or Amazon.
Well, while we're on the subject of figuring out how to remove a texture, how say you want to print something that has a specific texture, maybe like an orange peel type feel to it. Is there a way to do that yet, or is that not something that these printers will do yet?
They will absolutely do it. Whether the printer can do it's a different question than whether or not you can apply it. The printer comes down to your printer. The printer comes down to your material. The printer comes down to the slice. And we've covered that. How to apply it to a model, though, is I would call it an art form. Personally, there are a couple ways to it's called embossing an SVG texture that you can go grab off of many different places on the internet to a curvature in a parametric file. Not sure how to do it in some of the other CAD softwares, but it's relatively painless in Fusion. But I prefer to use Blender. Blender is a free open source software that you can go and get, and you can be just as afraid of it as I was. It is incredibly frightening. There's so much going on. It's used professionally in Hollywood to make movies. I won't even pretend to understand 1% of what Blender can do, because I've seen somebody use Blender. I'm not that. But what I did gain a decent amount of relatively small internet fame for was pioneering a new methodology for applying textures to STLs rather than to steps. So you can download any texture off the internet, off Thingiverse, open it up in Blender, go into the sculpt mode, perform what's called a remesh of it. And once you remesh it, it reconsiders it into a whole ridiculous amount of like 1 million polygons. Then you can import any bitmap, any JPEG, any SVG. You can import anything. And then the Sculpt tool in Blender has a myriad of really cool sculpting tools like edge and fill and clay and thumb and flatten and smooth. And you can say, hey, when you're doing this change to this mesh file, do it with this texture file I gave you. So you can take like a brick or a brick wall or the scales of a dragon, or you can take a PCB from a motherboard and you can have this cool little circuitry thing. And you can basically, what it feels like when you're doing it is you can basically open up MS Paint and spray paint a texture onto a 3D model is what it feels like. And then you perform what's called a decimation, which is to remove all of those additional polygons to just retain the external surface. Export that STL and print it the same way you would the original one.
There's a very similar thing in the software that I use, which is Lightwave, and ultimately you can have a thing called a texture map. And a texture map is something. It's a raster image, so you might take a photo of something, whatever it is, like you say, might be a brick wall. Anything that is white is highest, anything that is black is the lowest, and anything that is a shade of grey between that it falls in between it based on the intensity of that brightness. And then you set what is going to be the highest point. So I can say that the highest point is going to be 10 centimeters high, or the highest point might be 1 millimeter high, and then that texture map will be varied inside that. Now, texture mapping is something that's been around in 3D graphics for a very, very long time, and as a way of getting the appearance of a texture without actually having a texture. So in other words, you put something around onto a what is a very basic and simple geometric object, so easier for a computer to calculate, and then you put a texture map on it that makes it look like it is more complex than it is. But what you can now do, and I think this is very similar to what you described in Blender, is you can take that texture map and you can say, rather than just giving me the illusion of this texture, I now want this object to adopt this texture, actually have this texture rather than just the illusion of the texture. And then it will break it down into loads and loads and loads and loads of tiny little polygons and actually make that texture part of the geometry of that object, and then you could then export it and then 3D print it. And that sounds very similar to what you just described you're doing there in Blender.
But beware. I have taken small, very simple 500 kilobyte STLs. I've remeshed them. I've applied a whole bunch of cool textures to them, and without knowing the decimation tool existed, that 500 kilobyte file, I'll go and export that. If it's complex enough, I've gotten it up to 1.2 gigabytes for one STL.
Wow.
Okay. And that decimation brings it down. You understand the metric system. That decimation brings it down by a factor of 10.
10.
Only. So that 1.2 still got to be, 120 megabytes, which then you can run it through like 7-zip or any other type of compression tool that you use. And I can then usually bring it down anywhere from 30 to 60% more for transit. But it's still quite a lot, and it's kind of insulting when you export an STL from Fusion. It's like, oh, hey, 70 kilobytes, one little tiny texture, 70 megabytes. Like, oh my gosh, what is happening?
You've definitely got me wanting to experiment with this stuff now.
Yeah, that super scary Blender software. It's not scary for people like Bruce. That's his default. Overkill is.
I've never used Blender.
Yes.
No, I'm a big fan of Overkill. Yeah, don't get me wrong there.
Yeah, it's got it.
That's for sure.
It's Overkill.
I'm surprised your backup software isn't Maya 3D or something.
Another quick shortcut for I just want to throw it in.
Fire away.
The fuzzy skin setting in Cura. If you want just a little bit of texture on your object, there's a little checkbox that you just check in Cura or most slicers that'll say fuzzy skin, and that will add a little bit of perturbations on the outside of the model to give it a little bit of texture.
Does that kind of hide the layer lines doing something like that?
Prevents.
It does. It does hide the layer lines, but it makes different types of lines. So it's going to be a taste. It's going to come down to your preference and what you want your model.
I must give that a try. I must definitely give that a try. Okay, now Eric, I've heard you say Raspberry Pi several times while we've been talking here. And now I will just preface this by saying that I use a Raspberry Pi with my printer. I have, as I say, the Ender 3 V2, which has a pretty basic interface. There's not a lot going on there. And there's a little slot in the front for sticking an SD card, and there's really not that much going on there. But I have a Raspberry Pi with some software on it called Octoprint, which I am then able to bring up as a nice web interface on my computer. I can then control the printer from that using a web interface from my computer, or upload the files. It can store the files, and I can, and it has some fancy little tools, like I can watch it printing with a 3D simulation. I can connect up a camera. I can do, what do they call them? Those sped up videos. What do they call that thing? That's
Time lapse.
Time lapse. That's the word I was looking for. Now, okay, so that's what I use a Raspberry Pi for, but you're clearly using a Raspberry Pi for something very, very different.
I am. I'm actually loading it up right now to see if I'm in a position to be able to share this. I am. Would you like to see it?
Yes,
All right.
absolutely.
Let me see if I can do this. Present, share screen, window. Okay.
How ridiculous is this going to be?
It looks a
I'm
lot like
curious.
it's a lot, but it's not.
Yeah. I haven't
So-
used Clipper, but I've heard of it.
So don't think about Clipper. Think about Mainsail. Mainsail is an operating system running on Pi, the same way Octoprint is an operating system running on Pi. So Clipper is a firmware. So what you're looking at here is my Mainsail control of my printer. So I've got the webcam over there, and it's an $11 Amazon 1080p wide-angled camera. It was not nice. It was not fancy. But I do have the ability to come in here and click home and go to my webcam and watch it do my leveling. Not my leveling, my homing, I'm sorry. My G28 command. Hopefully it's not too much noise in the background. I have not replaced my motherboard yet.
No, you're fine.
Okay, because it is very loud for me. So yeah, I can sit here and I can control all kinds of things. Now, much like Octoprint, you have the ability to upload and print files the same way you would with Octoprint, where you can just say, hey, here's my G-code, please go print it. You do have the ability to control a couple other things about it, which is very nice. And what we'll talk about today is let's start with the basics. I can preheat this. I can type in 210 Celsius. I can type in 60 Celsius. I can click home, and it's going to start preheating it. So I know that I'm going to start printing soon. I know that I'm going to now open up Cura and start messing around and doing stuff. But it's going to get up to temp, so that way when I click upload and print and click go, it's going to start printing right then and there, ready to go. You can do that right now with Marlin. But what this does is quite unique. It's in my definition of the word, it's very space aged. If we open up a G-code file, like I said earlier, it takes coordinates and it says go from here to here with this amount of extrusion, with this amount of speed, and then do the next one. Clipper doesn't do that. Cura does that. Cura creates that G-code. And when I open up my Cura, and I think I can do this with relative ease, when I open up my Cura, I have one change between what you all do and what I do. And that is my start print and my end print commands. And I am loading up Ultimaker Cura over here. You can't see it. But this is all it is. It's nothing crazy. It's just a pretty web user interface. So I can control the print head. I can step things around. I can raise and lower the Z. I can perform a cooldown operation that brings it down correctly. I can change my manual fan speed. I can turn my filament sensor on and off. The machine velocity is nice, but there's a lot of bells and whistles and cool crap that you don't have to mess with. I have the same stuff you guys do. I can do my G-code files in a menu. I have my height map, my G-code viewer, my different machine information. I can see what versions of things I'm on, the information about the board up here, the information about the Pi down here. Mainsail is just a really pretty web wrapper for what it can do. What Clipper does is not seen here, though. And what I can do is I can show you my printer.cfg file, and I can show you that it's exactly what Octoprint does. Is it's these pins do this stuff. It's nothing interesting. There are some cool parts here, which is the BL Touch. So like this one in particular here. This says here's the pins for it. Here's my offset. Here's the speed at which it functions. Then I have my bed mesh speed. Here's my my minimum, my maximum. And you can see here that my probe count is running a 6x6 map for each one of these prints. So I'm doing, obviously, a lot. I'm doing a lot of sensing, whereas most, I think the Marlin one is like a 3x3 or a 4x4 for this printer. It's not a lot. And so I'm creating a very sophisticated mesh here. But that's not where the fun is. The fun is when you create a Klipper file. And what I really wanted to talk about there, if I pull up my Cura real quick, and I'm not going to show you much about Cura because you don't see much in it. Let me switch my presentation window real quick. I have to do present.
While you're switching, I do want to point out to anyone watching this that is thinking about getting into 3D printing, you don't need any of this stuff to start printing. You can buy a printer, comes with a little SD card, you can slice something you download, plug it in the printer, have at it. You don't need any of this stuff. This is
Correct.
just, next step stuff. But
I'm wondering if you all can see this or not.
Okay, you ready for me to add
I think so. I'm hoping you can see it. Okay, perfect. So all I did was I opened up Cura, like everybody else would. And then in my settings, I go to my printers, and I go to machine settings, and I deleted all the stuff out of here to end print and start print. That's it. And that's where it stops. And that's actually where I'm going to stop presenting, because the rest of this isn't something I can show you unless we go through a setup process. So conceptually, I want to slow this way down and explain the setup before I explain how it works, because the setup, I think, will make a lot more sense once you see how to get there. So as most of you are aware out there in the world, because I know all of you are aware, you take a Raspberry Pi, you put an SD card in your computer, put an image on it using Pi Imager or Etcher, whatever you feel like, take the SD card out, put it in your Pi, power it on. Simple. From there, when you used that, it is encouraged that you use the Mainsail operating system here, and you tell it what your Wi-Fi, SSID, and password are. So that way you can open up a web browser, and you can log into Mainsail like I just did. There's no magic there. But on the other side, when you go to set up your printer with it, you open up PuTTY or something else to SSH into your Pi. And then you say, hey, use this printer configuration file that I found off of the Klipper website for all the generics. So you can just search on their thing for the file for Ender 3 V2 or Ender 5 Plus. You don't have to know a thing. You just go find their printer file, put it in there. You run a couple commands, and they are go to this folder, run this command. For this printer, fill out these 5 integers. For this printer, do these 3 integers. It's different for every printer. Somebody else has done the work for you. You don't have to learn how to do a thing. Once you're done with that, you have to do your own what's called make file, so you just exit that menu, you type in make, and it sits there and does a bunch of stuff. Open up your preferred FTP software of choice and take that file off of that Pi. What it did then was it took your printer's configuration off the internet that you told it, and it said, hey, take this printer and apply it to this set of USB ports from this Raspberry Pi with this serial number and this yada, 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 yada. Make it work. Take that file, put it on an SD card, and just plug it into your printer and boot it up, and it wipes the firmware. From then, it knows I'm now on Klipper. Klipper was that file you just made. And that Klipper file says, I'm only going to let you talk to me from this Raspberry Pi with these USB ports and these numbers and stuff like that. Then you plug the USB cable in, you've now Klippered a printer. It's that simple. That's not why. That doesn't explain any of the benefits. That just says how you get from out-of-the-box printer, Raspberry Pi, Mainsail Klipper. In my opinion, that's a little simple. Do you all, before I go any further, do you all feel like that was simplified enough?
Clear for me.
I'm here for feedback.
I get it.
Okay. So,
Dan, are you with us?
What day is it?
So what Klipper is what we call a dynamic library of methods. So that G-code file we would refer to as monolithic. It says, go to this line, do this little step, go to the next line, do this next little step, repeat. Every one of those little code line parses relies on the intelligence of the processor and the memory of the motherboard and the printer. Klipper says, I don't trust you to do any of that stuff. Give me your motors, give me your stepper drivers, give them to me over the USB port, you're done. I don't trust you, you're not good. You're not good at doing this stuff. Then when you upload that G-code file out of Cura up to your Pi, it does two things. Not only does it ingest the file and save it to an operating system, the file system, it then converts it into a library of methods. And what it says is, I saw that you had me go from here to here, then from here to here, then from here to here, using these extrusions, using these speeds. That doesn't have to be 3 steps. That should be 1 step, and it should be curvature. So please go from here to here, boom. So it's less going, thinking, stopping, going, thinking, stopping, going, thinking. It's less of that and more of a, oh, you want to do this? Well, there you go. We're doing that now.
Here's a quicker way of doing it.
Exactly. So what it then does is it parses every single layer into a method. Every single layer is this many methods, this many movements. So in my experience, trying to push my Ender 3 V2, which was bone stock, brand new from Amazon, I overpaid for it. I was maxing out at 60 millimeters per second wall speed, and I want to say I crept up to 80 millimeters per second on my infills when they were straight lines. Today, right this second, my Ender 3 V2 with upgraded bed springs and ABL touch, that is literally it. I've not done any real modifications to it besides running Klipper. I have seen 209 millimeters per second wall speed on that thing. It's cleaner. It's cleaner than the 60 millimeter per second Marlin is, and it blows my mind every time.
Would I be correct in assuming, just based on having this printer in my office here, that when it is printing at that speed, it is incredibly loud?
Not at all.
Wow.
It has to do with the motherboard on a printer has what are called stepper drivers. I think I actually have, I've got a box. So here's my SKR. Here's my SKR that I have not yet put in. So what you see here are 2 different very interesting things. So this is a motherboard that do not have the stepper drivers soldered in place. They have just sockets for it. And you see the red up on the top of this board. That means that they are able to be replaced. You can get really nice ones and really cheap ones and really loud ones and really quiet ones. You're all familiar with the basics of sending electricity to an electric motor. If you have dirty electricity, it makes noise. If you have very clean electricity, it doesn't. So then what we have is this other very, very, I would call this comically large box. For when I open this, you'll see why that's comically large. Because when I open it, you see this big, gigantic pad that fills up these little teeny tiny chips. And these little teeny tiny chips are the stepper motors. And these are hilariously clean and sophisticated and nice and quiet. And they will then continue to control my exact same motors, not changing the motors out. But it will send a much cleaner signal with less noise and less loss to them to allow them to do the exact same thing that they're doing today at the exact same speeds they're doing it today with less noise. My Ender 3 V2 already has very nice stepper motors and stepper drivers. It doesn't make any noise no matter what speed I run it at. The increased noise would be like, I don't know, I guess it'd be like the rattling that it makes on my shelf. Because of the sheer speed of it. No, it's not substantial or anything. It is, I guess the noise that I hear is the fan is louder because it's hotter. It's really not noticeable. It's the same thing as running the printer. But what's interesting is I have much worse stepper drivers on my Ender 5 Plus. They're older. They're very loud. They're terribly loud. When I switched over to running Klipper because it ran them faster and it ran them using methods with less variance in them, it printed in higher pitches. The noises that it made for higher pitches, they were more consistent, and they eventually lowered the decibels due to that consistency of transitive voltage. So it actually made it quieter too.
Right. The next question I'm going to ask, and this one is for you, Kate.
Okay.
Is 3D printing just a useless hobby, or is it really a practical, or even potentially a profitable thing to be doing?
Yeah, that is a good question, because a lot of people think that, oh, you're just gonna be printing out little hello cats and boats and that's it, right? And to actually get your printer profitable, I think that's a lot of people online actually design their own product and sell it. Like, for instance, I'm designing my little Mackie figures, and while I'm not selling them because they do resemble a computer that's owned by a big company that's copyrightable and everything, I am giving them away as part of my Patreon gift. And that is something that I know people online, they print out. One of my friends actually prints out some of her models that she designs. She designs them in Blender. She does drones and builds like different cages and different drone camera mounts for GoPros and stuff, and she designs those. And she also has a 3D printer. She prints out those things, and she's able to make profit, right? She makes a design. It's something that people want. Not everyone has a 3D printer yet, and not everyone has the ability to print out something to that level of, it's rigid, it's the right, 3D printing, as we've discussed in the last 2 hours, is a very intricate hobby to get into. And so there's a lot of people out there. If you jump on Etsy.com, you'll see that a lot of people have started to spin up little homegrown shops where they will sell jewelry to things like even these little adapters that I printed for this SCSI SD. Those people sell those on eBay. Like, you can sell it and it can be profitable. The key would be to find something that is something that you can sell, something that you think that it's useful for somebody else, right? Or something that somebody else wants, and make sure you have the rights to use it. You can't just go and start selling things off of Thingiverse. Some people do, and that's technically, against copyright laws and stuff. So definitely reach out to the designer who designed it, or design it yourself, or hire someone that is a designer. That's what I do. I didn't design these little Mackies myself. I got my friend, who's a Blender artist, to design it for me. But I think even when you start talking about things like things that you print that you could have bought online, like, not only if you're not selling anything, you can save money by printing stuff like a shelf for your keyboard or a case for your phone. You can print out, I'm into synthesizers too. I print out little mounts for my synths so they can set at an angle. There's things that I could have bought online that I'm saving that money because I'm able to print it out. Cage for my camera I can put my monitor on it and make sure that the HDMI cable is snug in there, and I can bolt other stuff to it. That stuff I can print, but I could have bought it for $70, but I saved that $70 by printing it myself. So I think it's more than just printing out doodads. I think it can.
Well, there's really cool stuff people do. Like, there's one that I saw, and I'm weird, granted up front. I love coasters, any type of coaster. Like, mostly I use hard drive platters, but I like coasters in all shapes and sizes. This person 3D prints a really cool pattern, fills it with epoxy, sells it. Looks beautiful, super simple. And it's not even a pattern that they design. It's an infill pattern. They literally do nothing. They just said, this is the shape, infill it up to 5 millimeters high, epoxy it, sell it. It can be great. If you have a great idea, it can really work. and be profitable.
Well, look, I think we're probably going to call it a day here because, boy, we've been going for a long time. I thank you all very much for your patience. A huge thank you to you, Kate, and to you, Eric, for joining us today. Sort of your input has been fantastic, and I hope people have enjoyed watching this. And if someone is potentially looking at getting started in 3D printing, I hope we've sort of given them a little bit of information and maybe got them to the point that they do want to take it on. And I would basically say to anyone in that position, do it. Get into it. I promise you'll have fun. You'll tear your hair out a little bit as well, but you will definitely have fun at the end of it all. So thanks again to you guys for joining us. Thank you very much. And again, thank you to Dana and Jay for being here as well. If you have anything that you want to say about this show, if you have tips or tricks or anything like that, please leave them in the comments. We'd love to hear from you. And that's basically it from us. So I'll say goodbye to everyone and thanks again. So bye-bye.
Adios.
Thanks for having us.
No worries.
Bye.